Hey guys, Miss Fearing here. Welcome to Unit 8, Notes 3. We are going to go ahead and solve systems of equations by elimination now. So basically what we're doing for this is exactly what it sounds like. We're trying to add these two equations together and have one of them eliminate, one of the variables eliminate so that we can solve. So the reason we use this is because when you're graphing, you might not always be able to find the exact point where they connect. So we can't always use graphing as a way to solve these things. So we need some sort of mathematical way to do it as well. So the big thing that you have to keep in mind, when you're looking at these, you need to be in standard form for elimination. So basically that's ax plus by equals c. So you need the x and the y on one side and the constant alone on the other side, okay? Then you need to go, and the goal is to try to get one of the equations or one of the variables to cancel out when you are adding straight down. So you always want to add straight down and have one of those variables cancel out. If it doesn't, then you need to go ahead and you need to multiply the entire equation by something so that the numbers then match. Okay, so this will make more sense when we kind of get to an example here. Your last step then though is to take that variable that you just solved for and plug it back in to find the second variable, okay? So you need an x and a y for all of these. Let's look at this first example. So step one, standard form. Yes, the x and the y are on the same side for this equation and the x and the y are on the same side for this equation. So I am in standard form for both of them. So what I want to do is I want to look at this and I want to see if I add these straight down, do any of my variables cancel out right away? Well, I notice that if I have negative 4x plus 4x, that's going to give me 0 x's. They're gone. So now I can keep adding straight down. I have a 2y plus a negative 3y. I'm going to get negative 1y. And then I'm going to add 8 plus a negative 10. And I'm going to end up with negative 2. So now I'm just going to solve for y. To get the y alone, I need to divide by that negative 1. So I'm going to have y equals positive 2. So I have half of the problem done. I now need to take this y value and I'm going to plug it back into one of the first original equations to solve for the x value. So I'm going to go ahead and I'm going to use the top one. Does not matter which one you use. So I know that y is going to be 2. So I'm going to rewrite this, and when I get to the y value, I'm going to do parenthesis 2. And now I'm just going to solve. So I know that 2 times 2 is going to give me 4. I have to minus 4. So I'm going to get negative 4x equals 4, and then divide by negative 4. So my x is going to equal negative 1. So my final solution, just like when we were graphing, the point is where they're going to cross is negative 1, because that's my x comes first, and then y was 2. All right, let's look at this example here. First thing, are they in standard form? The x and the y are both on the same side. Now, second thing, if I add straight down, does anything cancel out? Well, no. Right now I'd have negative 6x and negative 2y. So to make my y's cancel, because the number in front of them is already the same, I just need to make one of them the opposite number. So I'm going to go ahead and I am going to multiply this bottom one, this whole equation, by a negative 1 because I need to change this negative 1y to a positive 1y. So that top equation is not going to change. I'm still going to have x minus y equals 9. And now the bottom equation, when I distribute this through to everything, I'm going to get 7x plus y equals to positive 7. So now I can add things straight down, and I'm going to get 8x. My y's are going to cancel because I have a negative 1 plus 1, and that's going to equal 16. And then I can divide by 8 to solve for x. So x is going to be 2. So we're going to take that 2, and we're going to plug it back into one of the original equations. So I'm going to go back up to that top one again. And I'm going to plug 2 in for the x because that's what we just found. So I have 2 minus y equals 9. And now to solve for y, I'm going to minus 2 first. So I'm going to get negative y equals 7. And then I have to divide by that -1. So I'm going to get y equals -7. So my final answer is an xy point. So my x was 2, my y was -7. Okay, let's look at number 3 here. So I need both of these to be in standard form. When I look at that first one, my x and my y are not on the same side. So I need to move this y to the other side. So I'm technically going to have 2x. That positive y, when I moved it over, is now going to be a -y equal to 7. And now I'm going to go ahead and I'm going to try to add to get things to cancel out. So I know that I need one of these variables to be the same number in front of it, but one be positive and one be negative. So I'm going to go ahead and I'm going to make my y's cancel out again. So what I'm going to do is I'm going to multiply this whole bottom equation. I need this to be a +3 in front of the y. So to make a -1 multiplied by something make a +3, I'm going to multiply it by -3. So I'm still going to have 6x minus 3y equals to 24. And I'm going to distribute that second one with that -3. So I'm going to get -6x plus 3y equals -21. Now I can add things straight down. So my x's are going to cancel here. My y's are going to cancel as well. So I have nothing left on this side. But when I do 24 minus or plus a -21, I'm left with 3. So this is one of those special cases. Remember, if I look at this, 0 does not equal 3. That is not a true statement. So since it's not a true statement, you are actually going to have a no solution as your answer. All right, number 4, my x's and my y's are both on the same side. So now I'm going to go ahead and I'm going to multiply by something to make the numbers the same because none of my numbers are the same in front of the variables. Now, if I'm looking at this, your x's, you can make your smaller number look like your bigger number. That's kind of your goal. But if I have 3, I can't really multiply 3 by anything to make it look like a 4. So I'm going to look at my y's. I make look at the smaller number first. I have a 2y. I can't really multiply 2 by anything to make it look like a -3 or like a 3. So what we're going to do is we have to multiply both equations by something in this problem. So what I'm going to do is I'm going to go ahead and make my y's cancel because one's already a positive and one's a negative. So I'm going to think, well, what number do 2 and 3, what number can I make them both look like? So I'm going to multiply the top one by 3 and the bottom one by 2 because I can make them both look like a 6. So if I do that, distribute this into everything, I'm going to have 12x plus 6y equal to 6. I'm going to do the same thing down here. Distribute that 2 into everything. So I'm going to have 6x minus 6y equal to 48. Now I can add everything straight down. So 12x and 6x is going to give me 18x. My y's are going to cancel. And we're left with 54. So now I can divide by 18. So x is going to equal 3. So now I have to take that number and plug it back into one of the original equations. So I'm going to go back to the top one again. So I had 4x plus 2y equals 2. And I'm going to plug a 3 in for the x. So 4 times 3 plus 2y equals 2. Now we can just solve. So I have 12 plus 2y equals 2. We're going to subtract 12 from both sides. So I'm going to get 2y equals -10. Divide by 2, so we're going to get y equals -5. And now we just have to write that as a point. So my x is going to be 3. My y is going to be -5. All right, let's look at this one. My x's and my y's are both on the same side, so I am already in standard form. So now I just have to multiply. So I'm going to go ahead and I'm going to multiply this bottom number. I'm going to make my x's cancel, so I'm going to multiply that by -3. So my top one's still going to be 3x minus 6y equals -6. And I need to distribute this -3 to everything. So now I'm going to have a -3x, a positive 6y, and a positive 6. So now we can add straight down. So my x's are going to cancel, my y's are going to cancel. So I got 0 equals -6 plus 6, that cancels as well. So I have 0 equals 0. This is, again, one of those special cases. 0 does equal 0. That's a true statement. So if it's a true statement, we're going to say IMS. There's infinitely many solutions. Last one here. So we want to go ahead and we want our x's and our y's to be on the same side. So we need to move this 4y over to the other side. So to do that, I'm actually going to have x minus 4y equal to 0 as my new equation. So looking at these two, I want to add them straight down. Nothing cancels, so I need to multiply. So if I'm looking at my y's, the smaller number is a 3. There's nothing I can really multiply a 3 by to make it look like the bigger number, which is a 4. So I'm going to make my x's cancel. I need to multiply the second one by a negative 2 because I need that 1 in front to look like a negative 2. So I'm still going to have the 2x plus 3y equals 44. I'm going to distribute this negative 2 to everything. So I'm going to have negative 2x plus 8y is going to equal 0. Now I can add straight down. So my x's are going to cancel. 8y and 3y is going to give me 11y. 0 and 4 when I add is going to give me 44. Divide by 11, I'm going to get y equals 4. So now I can take that. I'm going to go back to the original equations. So x is going to equal 4y. Again, I always just pick the top one. It doesn't really matter. Plug that 4 in for that y. So 4 times 4, x is going to equal 16. So if I rewrite that as a point, my x was 16, my y is 4. All right, you guys, this is not the easiest assignment, but you can do this. I want you to process through, think about it, ask questions as you're going, but definitely do not give up on this. Let me know if you need help.